before, from its external environment. It's called the what?
Plasma membrane.
Yeah. So we're going to peek at that plasma membrane today with chapter 5 and look at all of the junk that's in it. Okay. We're going to make sure we understand, however, what the plasma membrane's made out of. Okay. So when we take a peek at that, of what the membrane's made out of, we kind of start with our friend here. Yeah. That says C, right? That's actually a letter, an abbreviation, identifying an atom, which is on the periodic table, and all at once. What's the name of that atom?
Carbon.
There we go. We should know that from the assignment. And if I mention certain things that you just have no idea about, I just need you to see me then. I need you to see me after class. Because that's related to assignment 1A. And see what you don't know as far as those principles of biology. Okay? All right, so I know even if you're not saying it now, people are saying things now, that doesn't mean that the end of the world, that's the end of the world. No. That just means come see me. Please don't ignore it. If the things that I'm saying now or ask questions about, and most of the class is saying it, and you don't know, don't feel bad about it, okay? Just see me after class. You have a question? What's that?
Yeah. For future purposes, do you have like another schedule where like I can see other than like the
Yeah, that's why. Just email me and we can set up a certain time. Yeah, if it's not like right before class, okay? So I can try to work with you with that. Very good. Okay. And so basically, what we're looking at is the atom, the carbon atom. And what's special about him, and it makes him different than all the other atoms in the universe, at least most of them, is that he actually has how many electrons in his outermost shell?
4.
Beautiful. He has 4. That's a problem, right? Because the outermost shell wants how many?
8.
Nice. Which means he wants how many more?
4.
4 more. Okay, that's what makes him special. All right? And because of that, he wants the atom, the way it works is, if they want that amount of electrons in their outermost shell, if they want that many more, then that's how many bonds they're going to make with another atom. All right? So that was the whole purpose of that in assignment 1A. Make sure we remember that atoms, the big thing about them is that they interact with each other and they like to form bonds with each other. Okay? So carbon's special because if he wants 4 electrons, he's going to make 4 bonds. He's going to make 4 more bonds with other atoms that are also on that periodic table. Right? And because he can do that, right? And that's how we represent bonds in organic chemistry and such. Right? Right? Bonds. A lot of times those bonds are with the atom here. What's the one with the H here? What's he called? Yeah. Very good. I'll keep it up. Why don't you keep it there until if somebody comes in, show them that. Very nice. So what's special about him is that he makes so many bonds with other atoms, even himself. You see that? And that's what's really special there, right? He makes other bonds with himself, and you can keep putting carbons next to another carbon, bonded to another carbon, all the way around this room. And you get fairly what? Large molecules, right? Like on assignment 1A. One of those what? Large molecules is what we call carbohydrates, right? You got the same number of carbons as you have what? Oxygens. Right? And it's a lot of oxygens on there. A lot of oxygen on what we call carbohydrates. Okay? And the other feature related to oxygen, and he's very interesting. Why? Because oxygen typically wants how many electrons? He wants how many more for his outer shell?
2.
So he always wants what? To make 2 bonds with what? Another atom, right? 2 bonds. 2 bonds. Isn't that right? Very nice. And so therefore you get these oxygen bonded to atoms. But how many? Typically 2, right? 2. Yeah, because he only wants how many bonds? 2 bonds. Okay? So he's happy, and typically he does the same thing. Grabs that atom. What's that atom called again? Hydrogen. What's that molecule right there?
Water.
See, water. Water is very important for us. That molecule is incredibly important for us because that's basically what makes up, that's the most abundant molecule in what we consider our body fluids. And we're mostly made of what? Water. Because of that. Body fluids, it's a solution. Body fluids is a solution. What is a solution? A solution has two things. A solvent and a what? Solvent is the one that's in most highest number. That's the molecule that's in highest number. In this case, for our body fluids, that's going to be who? Water. But the other solute, the solute happens to go into water, becomes one with water, okay? And that's in the minority. He's the smaller numbered molecule. If glucose, for instance, is a solute, because he's becoming one with water once you put him in there, right? But he's in the minority. He's not as large a number as the water. Right? So when you have glucose in water, now you've created a solution. That's a solution, okay? And that's what our actual body fluids are. Our body fluids, okay, is a solution. Right? And its most abundant actual substance, the majority molecule is who? Water. So he's called a solvent. Right? You really have to understand that basic principle before we have a lot more fun here. Right? Because that process we come across all the time. Understanding a relationship that solutes do have with water. And it stems from this, right? Because this guy's an actual bully. Okay, that's what he is. You know, they don't say that in what we call biochemistry. But he's a bully because, and that's what they call him in biochemistry, the electronegativity, right? This just means that when he is making a deal, a bond with another atom, in this particular case, this bond being a covalent bond just means that these two atoms are sharing an electron. That's how he got those two electrons that he wanted. Actually got those two electrons because he's sharing hydrogen's electron, okay? And that's why he's got that extra one there. See? He's sharing hydrogen's electron here. Right? See, this is oxygen's electron. And that's what? Hydrogen's electron. See? Oxygen wanted another electron because he wants two, right? So what does he do? Picks up hydrogens, okay, for his shell, for his outermost shell. But hydrogen had the similar issue. He needed an electron too. So oxygen sharing his electron with him. When you have two atoms sharing their electrons with each other, then what kind of bond is that creating? A covalent bond. And so this is very important in what we consider biological molecules, okay? Because that's what creates these very, very large molecules, right? But in this particular case, our bully, because that's his personality, is not sharing what? Equally. If he's not sharing equally, then this hydrogen really doesn't have that electron really for himself. It's a little closer to the oxygen. He really, he didn't totally lose it, but he doesn't really have it, right? So his total number of protons are 1. That's all the number of protons he has, right? And what kind of charge is protons? Okay. And then he has what? Oxygen, but hydrogen has what? Not really an entire electron. Let's say it's half. And what's the charge for an electron? It's negative. So if we actually do the subtraction there, just simple arithmetic, and we add up hydrogen's net charge, what is his net charge going to be?
Positive.
It's going to be partially positive. You see that? Partially, if he had an entire electron, it would be 0. But because oxygen, who's a bully, he's kind of taking his more for himself, we got a what? A partially positive charge for hydrogen. It's partially positive. See that? Okay. We do the same numbers for our other hydrogen here, and then we do the same numbers as far as adding up the charge for oxygen. Well, you know he's the bully taking all these electrons, right? So now he starts to have more electrons than what? Protons, right? So his net charge is going to be what? Yeah. And so that's how the water molecule is. The water molecule is roaming around, and he's not a linear object. He's not linear. With those atoms put together creates a spherical structure. So I can't say, oh, well, on one side, this is what's happening, and on the other side, this is what's happening. I have to say, well, if it's a spherical object, just like the Earth, what does our Earth have? Poles, right? So what does it have? The what pole? North and the South Pole. You see that? Something's happening on the north that's totally different than the one side. Same thing here. For our water molecule, it has poles. On one pole, it's what? Positive. On the other, it's what? So that's why we call that molecule what? Being polar. It has polarity. See, it has poles. See, one thing on one pole, another thing on the other. But that's the same thing you used to play with when you were a little kid, right? When you were a little kid, you played with magnets, and at one end of the magnet was what? Positive. On the other end, it was what? You take another magnet with the same positive and negative ends, but you put this positive end with that negative end. What happened? Attractive force, right? Let's peek at that, right? Let's say that we actually did. Let's say that we did have another water molecule thrown in here. So that means, right, then that particular oxygen here, who has a what? Negative charge, would end up right next to a hydrogen on another water molecule. And what is that going to be? Just like when you were a kid playing with magnets, right? That negative is going to be attracted to the what? See, this is how actual water molecules do what? How they actually do form bonds with each other. Between each water molecule, there's a bond. Isn't that right? Typically, it's mostly involving who? Hydrogen. So what kind of bonds do we call those that have this attractive force created? Yes. Those are called hydrogen bonds. We went from the covalent bond to what? Hydrogen bond. Different type of bond. This bond is within a molecule. Intramolecular bond, right? But your hydrogen bonds are between molecules. Is that right? So those are between. What's that prefix for between? Inter. So your hydrogen bonds are intermolecular bonds, right? But that principle of polarity does a lot, even outside of just looking at water molecules, right? When we look at the fact that there could be other molecules that are polar, oh, we're looking at now what? A whole bunch of magnets. Yes. Even glucose himself, right? See, glucose himself, he's a special structure because glucose has a whole bunch of carbons. How many carbons? If you don't know what glucose is, right, that's all that is sugar. What does sugar have on him? On all of those 6 carbons is a functional group. See that part of assignment 1A? That has what? An oxygen and a hydrogen. You see that? Here's our bully again, right? If that's the case, then what's his charge? His partial charge is what?